Okay, so today I'll introduce you to the O.C.E. HISAOR development kit. It comes in a nice aluminium case with branding on the front there. So let's open up the case and see what we have inside. Okay, so we have the development board here in its anti-static bag. We have the software, which will either come on a USB stick or on a CD. Same softwares. Okay, underneath this then we have a MIPI camera. We have an LVDS to HDMI converter for connecting HDMI monitor. We have a USB cable to connect up for the serial connection on the boot. And we've got the power units here. And then we have an SD card with the Linux bootable development environment. And lastly, we have a set of keys. Okay, so having removed the items from the case, now let's set up the board for the first time. So we're going to need some power. Let's open this up. So we have our power lead. We don't need the keys for the moment. We will need the USB mini cable, which I will extract from its bag. Okay, and of course we'll need the development board. Okay. Very good. So we have the development board here. This one already has an SD card inserted. And with the various interfaces, power switch here. Okay, so let's just connect up the power. Okay, so at this point we have the power connected to an adapter there. It's 220 volt, but I think the power supply will work from I'm guessing 110 to 220. Into the power connector. We have the USB connector providing a serial interface connected into my laptop. And so let's, this is the power switch here where we apply the power, but before we apply the power, let's set up, let's apply the power to the board. Okay, a few LEDs come on there, and the board will have gone into the initial boot, which is in the eFuse ROM, and that should give us a menu which we need to connect to via the serial port. So, okay, so now that we have our USB connection, serial connection to the HisaorDevKit development board, we need to find out the port, the virtual COM port created. To do that, if you go into properties of my computer or my PC, go to the device manager, look at the ports. Okay, so we can see Silicon Lab, CP210, USB to UART. So it's COM3. Okay, so we're going to need this COM3 for the serial connection. So what probably the easiest serial software to use is PuTTY, available under Linux or Windows. So let's fire up PuTTY, and we've got to enter the select serial here, COM port 3. The baud rate is 115,200 bits per second. So let's open that. Okay, so we do have a connection now. It's prompting us for a boot source. So let's turn off the board and turn on the board. Okay, so it's going through a bit of initialization in the boot code, setting up the DRAM, and eventually comes up with a menu here. So it's this is an EVB DDR4 board. It's got options to boot. Number 1 to boot from the UART, 2 from the SD drive, and 2 from the SD drive, 3 from the eMMC, 4 from the SPI NOR flash, or 5 from the NAND flash. So we're going to boot from the SD card 2. Okay, so now it should be using U-boot to load Linux from the SD card. This is a 32 gig SD card. So we can see now it's booting up Linux. On this particular version of Linux, we've set up a fixed IP address of 192.168.1.31, as far as I recall. So as soon as Linux is booted, and this is a version of embedded Ubuntu. Okay, so we can log in here. It's not necessary to do this, but okay, so user is Ubuntu, UBUNTU. Password is OBT. Okay, so now we're logged in. And if we use ifconfig, we can just check the IP settings. Okay, so ifconfig is telling us that we have no Ethernet connection. That's no problem. Give me 2 ticks. We'll plug in okay, so I've now plugged in an Ethernet connection, and okay, it's come up, it's recognized the link, 1 gigabit link. So if we do ifconfig again, this time we should see up here that 192.168.1.31 and the net mask. Okay, so next then I already have VNC. There's a VNC server on this version of Linux, so let's use the VNC viewer to connect across the network to the development kit. I think the development kit we're connecting to is, so the connections for the VNC server we can see are 192.168.1.31 : the port number 5901, which is the default VNC port, and we can give it any name we like. So okay, that's set up. So now if we double click on that, okay, this connection will not be encrypted, we don't mind that. Continue. Okay, and the password here is 123456. Okay, so we're now in and we're connected to Linux running on the development board. So we're gonna okay, so let's take a look at the first and probably one of the better demos that you can give with the HiSaor board. This demo uses a USB camera which we've plugged into the USB port, and it's a Logitech camera. Okay, so let's open a VNC client to the machine. Okay, password 123456. Okay, so now we're connected to the HISAOR board running Ubuntu, and we need to go to the demo directory. By default, when you connect, you're connected as root. So the demos are in home, so let's open up a file browser. When you're opening file browsers, by the way, just give it a couple of seconds to open it up, because it's not as quick as from the SD card as it might be from on your PC. So we want to go to home. Okay, let's find home. 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 Ubuntu. And if we go to the workspace folder, and then to the demos. So here are the pre-canned demos, if you like, that come with HISAOR. So the one we're going to look at is YOLO V2 TinyCam. Okay, so let's open this folder. So here it has all the makefile and the source code, everything associated with this demo. So I'm going to right click here, open a terminal, which will open it in this folder. Okay, so we now have command line in this folder. To run the demo is run.sh. Okay, and this script will load the drivers if they're not already loaded. Then it'll, as you can see there, create a neural network and then verifying it. Verifying the neural networks using OpenVX tends to take a good bit of time. Can take anything from 10 to 30 or even more than 30 seconds. But once this demonstration is running, the actual processing of each image captured from the neural network camera is about 5 milliseconds, in fact 4 milliseconds. Okay, so what we're looking at here is it's opened up a window and it's capturing from the camera here the image, and it's identifying items in that image. So you can look at the source code to find out the list of items that this particular YOLO V2 model has been trained with. You can see it's identifying me as a person, the dining table, and occasionally in the background it's coming up with the chair. It's identifying this as a bottle. There we go. The number after the identification is the probability, and I think it displays a probability of anything greater than 0.25. You can check all this in the source code. So that's a bottle. I don't know, let's try a cup here. Did identify this earlier on. Okay, sometimes it identifies it, sometimes not. Let's just put it down there. Oh, there it is. It's seeing it as a cup now. Mobile phone maybe. Okay, well sometimes it identifies cell phones. Okay, well look, that's this is a demo where in the screen scrolling it there we see every time it processes an image it outputs the time it's taking about 4 microseconds on average to process each image captured by the camera, and it's doing that obviously in real time. Okay, so that's the that's probably the first and easiest demo to show. Just stop that. Okay, so let's look at another demo. In the demo directory there's a folder called YOLO v3 tiny plain int 8.cam. Let's go into this folder. So this folder, or this demo, processes an MPEG video, and as the demo runs we'll be able to see the video and what it's identifying in the video using the YOLO v3 model. Okay, so again, once we're in the folder, if we right click on this we can open a terminal in this folder, and run.sh should run this particular demo. Okay, so again what this will do is it'll create a neural network and then we'll verify it, which again, as I said, the verification of the neural network using OpenVX can take between 10 and 30 seconds depending on the complexity of the graph created in OpenVX. So when it's finished, the verification goes into execution mode. It will start processing the MPEG video and identifying, in this case we will see, okay, so here's the video, which we can see is plain and it's moving along, and if we look, it's taking about 5 milliseconds to process each image. So on the screen then we see the green box around what it has identified as the object being a plane, the percentage certainty 30 to 40%, and the number of microseconds taken to identify it. So as the video moves along, there's varying certainty in relation to the object, and the processing time tends to be fairly similar. So this is a relatively good demo for possibly, I think, maybe for defense applications. Okay, so this is the demo of the LENet model. So again, as in the other demos, if we go into the folder, so this demo imports, processes a tensor file here and uses the model data is contained in this file. So to show you what happens when you execute it, let's open a terminal in the folder. So just actually, if we look at the actual script to run it, so it sets up a few logicals here, then it tries to install the driver if it's not already installed, Then finally it runs the executable lenet uint8, and it passes in the data file and the tensor file and processes them. So it uses OpenVX to do this. The uint8 just indicates that they're unsigned 8-bit integers for the representation of the data in the model. So let's actually run it to see what happens. Okay, it's creating the neural network and it's running a verification of it. When the neural, the graph within OpenVX has been verified, which again I mentioned before takes between 10 and 30 seconds, then it'll process the file. I think it only processes the tensor file once, and should output how long it took to process the file. So this demo, like the other demos, can be built to run on your PC or to run on in the simulator on the PC, and you can compare the processing. You compare how long it takes, for instance, in the simulator, I suspect quite long, as on the actual board itself, on the HISAOR board. So model is still being verified. I expect it to process the file any minute. Of course, the verification only happens once at the very start when the application is run. So it should start to execute any minute, he says. Okay, so the verification of the graph took, in this case, is that 110 seconds? I'm not 100% sure about that. And it runs once, and the run took less than a millisecond, and the top items identified by the model were classes 0, 5, 6, 2 and 1. So I think you would have to look at the source code to see exactly the meaning of those. Okay, in this session we're going to look at the Linux Acuity tools. These tools provide a number of scripts to convert existing models from Caffe or TensorFlow or some of the other standard formats into C projects that can then be imported, well, that can then be built under the environment which you want to run your AI model, and offload through OpenVX, offload the processing to either to a simulator in the development environment, and in the final target environment to offload it to the target hardware. So the first thing you have to do is you have to get yourself either a Linux machine, or in our case we're using a VM, which I believe is using the virtual machine I'm about to show you. I think will, let me just fire it up here, VMware Workstation version 3 player. So this is a 64-bit version of Ubuntu with the tools installed. So I'm just firing up or starting that virtual machine now. So essentially you want to get yourself a clean version of Ubuntu. We in this case found it easiest to use the latest version of Ubuntu. What you need to do then is, if you go to open the document Vivante VIP Acuity Toolkit User Guide. So if you open that up, in section 2.2 there's a part here about installing the tools you need to run all the Acuity scripts. So we can see here 2.2.1, install Python 3, install TensorFlow, install the Acuity package for pip, so there's a series of, so here we need to install TensorFlow, Astor, NumPy, Skippy. So all these utilities need to be installed, and they need to be installed without errors. There is a verify script which we can take a look at after you have installed the tools, which will validate if everything has been installed correctly. Okay, so let's go back to our version of Ubuntu. Okay, so I need to log in here. Okay, so I already have a window open on this version of Ubuntu. So let's go. In our case, we have installed, there's with your development kit, you will have a zip file or a tar file with YL Acuity Toolkit shell scripts. When you unpack that into a folder, you will get the following examples. So these are different models: LENet, MobileNet SSD, Res, and YOLO V2 Tiny. So what I'm going to do is take the LENet model. So you will have these, as I say, with your development kit. And if you want to run the scripts to create the projects targeted at the HISAOR hardware, there's a script called go.sh, and go.sh takes as a parameter the name of the folder that it's going to process. So let's open up a terminal in this folder. Okay. Files. Open and terminal. Okay. So let's maximize this window to make it easier to, it's not that easy to see really. And okay, so we're in the correct folder. So let's run the Go script. So the Go script has all the commands needed to convert the models in the various folders. So if we do go, and let's take LENet first. Oh, okay, I should have pressed go.sh, I think. Okay, so this is converting an LENet cafe model, and it is executing all the different commands, acuity commands, to convert the model. So it can take a little bit of time depending on the power of your machine, and what I would suggest is that when you try this, you go through the log afterwards and try and work out all the different operations that are going on here, because I'm not fully familiar with them myself at this point. Okay, so still converting, quantizing, creating the project files. Could be finished. Let's have a look. Okay, so it's now generated. Let's just minimize this folder again. If I can. Okay, let's just go back. So in the LENet folder, we will now see it has created a workspace folder. In that workspace is the new LENet uint 8 model. And so this is basically a project that uses OpenVX that can be built to run either in the simulator or on the target hardware, depending on where the make file, depending on the libraries read in by the make file. So what we need to do next, well, we could, in theory, we could continue working and import this project into the Vivanti IDE on Linux. However, I prefer working with Windows. So what we need to do then is transfer this project to a folder on our PC. So let me go up a level here. Okay, so I am going to take the complete folder here. So let's right click on that, copy it, and okay, let's see if we have mapped this to a folder on my PC. Mount. Okay, so there isn't any mounted file systems on my PC. So to mount one, let's go to virtual machine settings. Let's go to options, shared folders. I think if we disable them and enable them, it will remap the shared folder. And you can see the shared folder here is C users Barry downloads. So let's disable it. Okay. Now let's go back to player, manage virtual machine settings, options, shared folders, always enabled. That's okay. Right. So now let's see, has it mounted, or do we have to reboot? Okay, so go to computer, mount, Damn it. Okay. So it looks like when we do that, we have to reboot Linux to ensure that it's mounted. So, okay, well, if we have to reboot Linux, we have to reboot Linux. Let's go down here. So shut down now. Okay, so our Linux VM is being shut down, and we will power it up again in a second, hopefully to see the mapped folder. Okay, so the phone isn't connected. Okay, yes, this is okay. Okay, so it's powered down. So now let's go and power up the VM again. And when we power it up this time, I am expecting this folder to be mounted. So we're doing all this just so that we can copy files fairly seamlessly between our Linux VM and our Windows folders, where we have the Vivanti IDE installed, and we're going to build the project created by the Acuity tools. Okay, so this is not a particularly powerful PC, so it will take a minute or two to boot it. So these tools, the Vivanti IDE and the Acuity Toolkit, these are available free of charge when you buy the HisaorDevKit. However, you do have to sign an NDA agreement with VeriSilicon to obtain the license to run the Vivanti IDE. It's fairly straightforward, and we will provide the contact details in Europe to obtain the license. I think it took us a day or two here to obtain our license. Okay, so our VM has rebooted. Let's now log in. Okay, it's a bit low on file space, don't worry about that. Okay. So, should appear the main screen any minute. So again, to remind you, what we did is we took the LENet and the LENet example provided with the kit, and we want to now, we ran the Acuity tools, which produced a C project to run the model. This C project needs to be built, so we're going to copy this, and I'm hoping this time that we do have, okay, oh, damn, why is, okay, so I am going to stop this recording and go and fix this issue and then resume. Okay, so here we are. We've run the Acuity Tools, the Go script on the LENet model, and we want to copy this model, the project files and anything we need back onto a Windows folder so that we can build them on the Vivanti IDE under Windows. So let's copy to, and let's go to the area we've mapped on our PC. So it's in the mount folder, HDFS, downloads, and I'm going to copy it into the Barry directory on this folder. Select. Okay, so that should have copied. Let's minimize that. Let's go to our downloads folder and to Barry. Okay, here it is, LENet dated. Okay, workspace. Okay, so now so that's it on the Windows. So the next thing we want to do is, having installed our Vivanti IDE and obtained a license from VeriSilicon, let's fire up the IDE. So this is the IDE, and this is the workspace I have, Barry Documents Workspace. Okay, I already have a number of projects, one of which is the LENet Uint 8. So okay, what will I do? Will I delete this? Let's delete this project. Delete the project's contents from disk. Okay, so that project is now deleted. Let's go to where I have this folder in my documents. So if we go to workspace, Viv, okay, check there's no LENet there. So there's no LENet folder there. Now let's go to downloads, where we, okay, this is where we copied our LENet, and the project is actually in this file here. This is the new project created. So let's copy this folder into our workspace. This is my workspace. Okay, so folder is now copied into the workspace. So if we go back to the IDE, what we need to do now is import this into workspace. So if we go to import existing projects into workspace, we've got to select the root directory. So if we go to my documents, Viv 5.2, LENet Uint 8, there it is, finish. Okay, so now we have the C project included into our workspace. Okay, so the first thing I think we should do here is build it and check, does it build straight as produced by Acuity. So to build it, we'll click on the build icon. Okay, so there's a few warnings from the compiler, so let's just have a look. I don't believe there's anything to worry about. long int has type U64 and T. Okay, so these are fine. So the project is built. And it's built with the compiler to run on my PC. Of course, it will offload it has all the calls, the OpenVX calls, to offload the neural network processing for the model to the target hardware. However, in this case, we're going to set up to use the simulator which comes with the OpenVivanti IDE. So what we need to do is we need to create a debug configuration to tell it what to do when we run this particular executable. So let's have a look. Okay, so I don't see any, okay, so there's no debug configuration for this. So let's okay, so let's copy an existing one. We'll call it mobile uint. So if we right click on that, we can duplicate it. Okay, and what we want to do is, this model is called lenet underscore uint8. lenet underscore uint8. Okay, that's the name we're giving it. We have to now browse to the executable. So we go to our workspace, lenet uint8. The executable is in the debug folder. There's the executable. We have to tell it the main project folder. So lenet uint8. There we go. Now there's parameters. Okay. So this, well, let's run it with no parameters first, just to see what happens. Okay, so now we've created that. The environment, there's nothing in particular needs to be set up there. With the debugger, okay, so from the top, stop at start of main. Okay, let's do that. So what is the target? Okay, the target is the VIP. There's only one option, PID 0x4A4, so let's do that. This is the simulator. Let's take the default pair of ports, 6060 and 6061. Don't think something else needs to be set up here. Okay, so let's apply that, and now let's debug the application we've just written. So it rebuilds it, interestingly enough. There is an option to disable that, but okay, so now it's opened up the debug perspective, and it should it will be getting ready to run this on the simulator. So now it's stopped, it's opened up main, and it has stopped running at the first statement in main. So we're just going to press resume. Okay, so when we pressed resume, down in the console window down here, we've got a message from the application which is usage blah 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 blah. We should have passed a data file and an input file to be processed by the lenet executable. Okay, so what we need to do next is go into, okay, let's close our debug perspective because we're finished debugging. The program has exited, and we need to go back to our debug configurations, and we need to set up our program arguments. Okay, now the first, let me just move this here. So the first argument is the data file, and this is the data file here. So let's just see, okay. Let me just go to just to get the name of the data file, lenet uint8.export.data. Okay, that's that. copy, sorry, rename. Okay, I'm just doing this to get the name of the data file. Okay, so copy that. Let's go back to our IDE. So the first argument is the name of the data file. The next argument is the name of the file, the tensor file we want to process. Okay, so let's go back to that. And the tensor file we want to process, strangely enough, isn't in the project directory, so we need to go and take that. It's at the top level directory. It's here in the iter. This is the tensor file here. So let's copy this file. Okay, well actually let's rename it first so we can get the name of it. Okay, let's go back to our IDE. Now we've given it. Okay. However, that file isn't in the project folder where the program's going to look. So let's see what happens when it tries to run it. Finds the data file, but not the. Okay, so now we're in the debug. So simulator. Okay, so the error. So it got an error getting the tensor data because it couldn't find the file. Straightforward. Okay, so now we need to go back. Get the tensor file, copy that to our workspace folder, LENet uint8, and we copy it just into the main project folder here. Paste that. Okay, so now we have a file. Okay, let's go back. Let's shut down our debug and let's go again. So now this time, okay, so it's going a bit further. We should see some output at some stage here on the console. So the program is executing. We can see that because there's no option to resume and there is an option to stop, so it's executing on the simulator. Well, when I say it's executing on the simulator, it's running on the PC and it's passing the neural network calls to the simulator. So we can see the simulator can be quite slow. So let us just continue to wait here. Okay, so it's got to one part in the simulator. Now we need to press resume again. Okay, and now it's doing the various convolutions. As I understand it, these messages here are messages from the simulator indicating what's going on. Okay, so now the LENet has completed, it's verified, it created the graph, and it ran identifying the objects in the tensor file, I guess, and this would be the probability of that class 1 object, 0.999. So we've gone through the process here of taking a model with the Acuity tools, creating a C project, copying it to a Windows folder, importing it into the Vivanti IDE, and running it in the debug tool. So that's all for this session, and we should start the next session shortly.